Today I'll talk about isobaric process. An isobaric process occurs at constant pressure, means del P is equal to 0. Now, first law in isobaric process. In an isobaric process, the heat added Q goes into changing the internal energy del U is equal to N CVD del T and doing work on the surroundings. So W is equal to P del V, that is NR del T. Therefore, the total heat Q is related to the internal energy change and work done by Q is equal to del U plus W. So since W is equal to NR del T, we can express the heat added isobaric process as Q is equal to NCV del T plus NR del T. Now N and del T common, so CV plus R. So that CV plus R is nothing but Cp. So Q is equal to NCP del T. Now we know that first law of thermodynamics, del U is equal to Q minus W. So here Q is the heat added or removed from the system, can be positive or negative. W is the work done by the system or on the system, can be positive or negative, and del U is the change in the internal energy. Now here isobaric process, an isobaric process occurs at constant pressure, so del P is equal to 0. So work done W, work done is as the gas expand or contracts, so W is equal to P del V, so that is NR del T. And heat transfer Q, so heat is transferred to or from the gas resulting in temperature change, so Q is equal to NCP del T, where Cp is the molar heat capacity at constant pressure, and change in internal energy del U, similar to the isobaric process, the internal energy depends on temperature change, so del U is equal to NCV del T. Now here is the visual example. Consider heating a gas in a cylinder with a movable piston. The gas expand doing work, and both temperature and volume increase while the pressure remain constant. Now the internal energy in ideal gas is always given by del U is equal to NCV del T. So N is the number of mole, Cv is the molar heat capacity at constant volume, and del T is the change in the temperature. This equation hold true for all processes including isobaric constant pressure process, isobaric process and adiabatic process. This is because the internal energy depends only on the temperature change for an ideal gas. So for an isobaric process, the total heat added or removed is given by Q is equal to NCP del T. So where Cp is the molar heat capacity at constant pressure. Now here if I change from one state to another state, so what will be the work done Q and internal energy change? So pressure remain constant, so P is a constant. The system moves from P1 V1 T1 to P2 V2 T2. So now here P1 is equal to P2. So that's why it is called isobaric process. Work done W, work is done as the gas expand or contracts. So W is equal to PdV, that is NR del T. So that is NR T2 minus T1. And heat transfer, heat is added or removed from the gas causing temperature change. So Q is equal to NCP del T. So NCP T2 minus T1. So where Cp is the molar heat capacity at constant pressure. So now change in the internal energy del U, that is internal energy depends on temperature change. So del U is equal to NCV T2 minus T1. Now here in example, in a cylinder with a piston, the gas expand and work is done. Heat must be added to the maintain the temperature increase. So V2 is equal to V1 T2 by